of course, as a federal state initiative, HeFDI, we closely monitor what's coming up as services from the NFDI consortia, as we do consulting on researchers and their research data management basically every day, and they ask for services which they can use. And we were very happy to see RADAR4Chem, a repository for chemistry data, arising on the horizon. So I'm really happy to have you here today, and I'm happy to introduce you. Kerstin Solter works as a product manager for RADAR at FIZ Karlsruhe, and Christian Bonato-Minella works as a project manager at FIZ Karlsruhe in the task area repositories at NFDI4Chem. And of course, NFDI4Chem is one of the consortia of the National Research Data Infrastructure, and they all set up services, and we are very happy to have a look today at a very special service. And before I hand over to you, let me say a few words on our federal state initiative on research data management. It's HeFDI, Hessen Research Data Infrastructures, and 11 universities and universities of applied sciences work together to set up generic services, not subject-specific services, generic services for our researchers on research data management and infrastructure. And well, generic services are very interesting, but for researchers, they very much need discipline-specific or subject-specific services to really handle their data properly according to FAIR principles. Well, we are very keen to hear from you all about RADAR4Chem, and I'm very happy to hand over to you, and here you go.
Okay, thank you very much for the kind introduction and inviting us to give this presentation. So today I'll be introducing our chemistry consortium, NFDI4Chem, and the task area 3. The task area called Repositories, led by Felix Bach, our department leader. My colleague Kerstin will instead present our repository, RADAR4Chem. But so let's get into it. So as you might know, probably in 2018, the NFDI, so the National Research Data Infrastructure, was established, funded by both the federal government and the states. Its primary goal is to enhance and create comprehensive research data infrastructure and management. This includes providing essential tools, training, and promoting a cultural shift towards better data practices. Importantly, this initiative is a key part of the federal government's digitalization strategy aimed at modernizing our research data is handled and shared for greater efficiency and collaboration. So the NFDI in Germany comprises a network of consortia, each representing and supporting distinct scientific disciplines. For chemistry and related fields, several consortia have been established, such as NFDI4CAT, which focuses on catalysis, and NFDI4MATWERK, dedicated to material sciences. In addition, there are consortia like FAIRMAT and NFDI4INCH, which concentrate on data infrastructure for material sciences and engineering disciplines, respectively. Each consortium works to develop tailored data solutions, ensuring that research across these fields adheres to the FAIR principles, that is, making data findable, accessible, interoperable, and reusable. But where are we? We are a by the community for the community project, comprised of members from the research community, so the active researchers, the research data infrastructure institution, such as FIZ Karlsruhe, the learned societies, such as the Gesellschaft Deutsche Chemiker, and we also work closely with our advisory boards from industry and publishers. The slide is always a pleasure to see. It really highlights the incredible reach of our partnerships with collaborators in nearly every state of Germany. It's a powerful reminder that this is truly a unified effort, bringing together expertise from across the country. It's for us great to be part of something that fosters such a widespread collaborations and impact. Last but not least, we are also embedded internationally, such as it is displayed in the slides on the Research Data Alliance, the UPAC, the Science Cloud, European Open Science Cloud, and the GoFair initiative. So today in chemistry, much of the data is still managed in a traditional analog manner, often written by hand in lab notebooks, while modern instruments like nuclear magnetic resonance and liquid chromatography spectrometer generate data digitally. This information is typically stored on local servers without an integrated information flow, limiting accessibility and reuse. The biggest challenge, however, lies in how data is published. Chemical data often ends up in a PDF or an image in scientific journals, stripping away its original richness and usability. So this practice is actually unfair, and it contradicts the FAIR principles. The FAIR principles are standards that ensure data remains valuable for future research, fostering transparency, collaboration, and scientific advancement. But how can we make the current status quo in chemistry fair or fairer? Our vision for NFDI4Chem is fundamentally different. It represents a quantum leap beyond the status quo. The aim is the full digitalization of the data workflow from the earliest time point in the lab to the final data publication based on open standards. Starting from the experimental data in the lab, we will capture information in the electronic laboratory notebook in semantically rich form, together with data from instruments kept in LIMS to enable the data analysis locally. From there, rich data will be flowing into local repositories, and from there, FAIR data can flow into our public repositories, adhering to open standards, so they can be reused by everybody in the world. It is nearly impossible to make all data fair. You need to work fair from the beginning. But how do we intend to make this possible? So here you can see that at the core of our strategy is the smart lab, outfitted with the ELN, so the lab notebook, where data can be seamlessly fed into repositories for centralized storage. This setup requires dedicated software, along with carefully designed standards and policies to ensure interoperability across platforms and systems. To engage the wider scientific community, we provide a portal featuring help desk, then a knowledge base, teaching resources, training opportunities, and advanced search functions. So a smart lab isn't simply about touchscreens or flashy interfaces in a smart home. It's more about the seamless interconnectivity of the entire research workflow. From the outset, data is acquired digitally in modern instruments, are collected in ELN, enriched with detailed metadata to ensure context and quality. Researchers can plan experiments, make annotations, and deposit spectroscopic data directly in the ELN and internal repositories, where it can be analyzed and prepared for publication. This approach supports FAIR principle from the beginning, ensuring data is findable, accessible, interoperable, and reusable at every stage. But what's the vision of the task area 3 repositories within NFDI4Chem? So this slide outlines the key objective of TA3, those we established at FIZ, which is the leader of this task area. We want to offer storage and long-term archival. We'll ensure that all research data is securely stored and preserved for future access. We want to enable data publication with rich metadata. By providing detailed metadata, we make it easier for others to understand and use the data. Provide discovery of and access to research data. So our goal is to facilitate easy discovery and access to all relevant research data. We want to ensure the interoperability of data and services, which is crucial for seamless integration across platforms and disciplines. Integrate repositories into a smart lab environment, because we aim to create a cohesive ecosystem for researchers. Improve reliability and sustainability of service. Our focus is on maintaining dependable and long-lasting data service. We want to enable use of chemistry data. We want to make chemistry data reusable across various fields, including application in artificial intelligence. This comprehensive approach will enhance the accessibility and utility of our research data. The federation of the core repositories within NFDI4Chem include includes 7 German-hosted repositories. ChemOcean, hosted at KIT in Karlsruhe, deals with data related to chemical reactions and chemical substances. It can also be used in conjunction with the ChemOcean ELN. NMR Archive, hosted at FSU in Jena, is a new NMR spectroscopy data repositories and analysis platform. MassBank EU, hosted at UFZ in Leipzig, is the first public repository on mass spectrometry data. SupraBank is a specialized database hosted at KIT in Karlsruhe, offering unique data on intermolecular and supramolecular interactions. FrendaDB, operated by the Beilstein Institute in Frankfurt, is a repository for enzymology data. DeepSpecDB is an under development and focuses on Raman and infrared spectroscopy. And Nomad, hosted at the Max Planck Computing and Data Facility in Garching, plays a role in theoretical and computational chemistry. We continue to collaborate with them to evaluate data exchange interfaces and co-design functionalities. And then we have RADAR4Chem, hosted at FIZ Karlsruhe, which is a feature-rich repository covering complex data sets from all domains of chemistry. But Kerstin will tell you later more about it. We also included in the bottom, as you can see, 2 associated repositories in the field of crystallography, such as the Inorganic Crystal Structure Database with over 300,000 crystal structures, and the Cambridge Structural Database with over 1 million structures. Each repository is dedicated to key subdisciplines in chemistry, developed as an individual service. These repositories are tailored to the specific needs of the community, with a primary focus on molecular data. TA3 has established a virtual environment of interoperable feature-rich repositories trusted by the community and endorsed by journals and funding agencies, such as Angewandte Chemie International Edition, ChemBioChem, Journal of Natural Products, and the DFG Good Scientific Practice. The core repositories were selected based on quality criteria, which will be outlined in the next slide. Nevertheless, TA3 continuously monitors and evaluates global chemistry repositories, those including also beyond Germany that meet technical benchmarks will be onboarded and integrated within consortium service such as the ELN and the central search. In summer 2023, we carried out an analysis of repositories for chemistry data in RITRI-Data, so the German repository registry, through the application of several criteria shown here on the right that were essential for our scope. Only 12 repositories remained and are shown in this table. As you can see, of these 12 repositories, 7 are part of the NFDI4Chem Federation. Based on the NFDI4Chem community survey, a list of the most common data types and formats of the community has been compiled to suggest suitable, trusted, chemistry-friendly repositories. This decision tree here will guide users to quickly select a suitable repository for publishing their research data. I encourage you to go to our knowledge base to find out more information about that. In this specific case, you can see that if I want to store my multidisciplinary data in a repository, the best fit would be RADAR4Chem. RADAR4Chem is part of the NFDI4Chem knowledge base, as I mentioned before, of the NFDI4Chem Fair Sharing Collection, so a collection of repositories and standards and policies relevant to the chemistry community and meet the requirements of Task Area 3. And also of the NFDI4Chem Search Service, which harvests and indexes metadata from currently 140,000 datasets in the NFDI4Chem Repository Federation. Here you can see the webpage of our knowledge base, and with our article now to choose a repository with the federation, which is supposed to guide the users to choose one. This slide shows the fair sharing collection and its relational graph, representing each fair sharing record and its place within the broader landscape of interconnected database, standards, and policies. RADAR4Chem is connected to the TAB Hanover Search Service, the central hub for accessing and federated repositories of NFDI4Chem. The TAB Hanover Search Service currently includes approximately 140,000 datasets from key repositories such as ChemOcean, MassBank, NMR Archive, Darus, and RADAR4Chem. is designed to streamline data discovery. This service allows users to search not only by keywords, but also through advanced options like chemical structure codes, including the INCI, so the UPAC International Chemical Identifier, molecular structures, and associated analytical methods. This functionality supports targeted searches, making it easier to locate precise datasets within the vast landscape of chemical data. The search service is also continuously updated to align with the latest standards, particularly MICI, so the minimum information about a chemical investigation, and current metadata schema releases, ensuring compatibility and enhancing data quality. This flexibility allows researchers to benefit from a reliable and up-to-date resource, making the search service an essential tool for data-driven research in the chemical science. And with that, I'll hand over the presentation to my colleague Kerstin, who will delve deeper insights into the specific RADAR4Chem. So I thank you so far.
Yes, thank you, Christian. And I now have also moderation rights. Perfect. Yes, let's now focus on RADAR4Chem itself. Yes, RADAR4Chem allows fair publication of research data from all disciplines of chemistry, and the service is available since March 22, and it was developed in the framework of FIZ Karlsruhe's participation as co-applicant in the NFDI4Chem consortium. RADAR4Chem, it bases on our generic research data repository RADAR and uses the same software stack and software architecture. RADAR itself, it was developed within its DFG project, and it went into production in the year 2017 and is nowadays an established repository for generic research data in the academic community. RADAR4Chem offers the comparable functionality and the same reliability as RADAR. For example, it can be used for all data types and data formats. Research data are each stored in 3 copies in 3 locations, and we guarantee a long-term availability of the data for at least 25 years. Next to this, RADAR4Chem offers chemists the benefit that is very low threshold to use and free of charge. No contract is needed for using RADAR4Chem, and it can be used by any academic chemist independent from the home institution. So for RADAR4Chem, several NFDI4Chem co-applicants cooperate with each other to run and to finance this offering. Next to FIZ Karlsruhe, these are KIT and TU Dresden. We at FIZ Karlsruhe, we are the operator of the service, we develop the software, we administrate the service, we advise users, we authorize them as data providers, and we also take over the DOI registration fee. The research data itself, these are stored in 3 copies in the data centers at KIT and TU Dresden. And these computing centers, they provide a storage volume of currently 3 terabytes for the publication of research data free of charge as their contribution to this service. And that's why we can offer RADAR4Chem for free to researchers in chemistry. What are the use cases for publishing data in RADAR4Chem? As I said, it allows publication of all data types and data formats, and it complements the portfolio of already existing subject repositories in chemistry. Therefore, it's suitable for all the data sets, especially, of course, for those which do not yet fit in any existing subject-specific repository. For comprehensive and complex data sets, which have various types of formats and data types, for interdisciplinary or multidisciplinary data sets, or even for large data sets. Here, let's have a look at the RADAR4Chem core functions and features. As I said before, for each published dataset, we guarantee a retention period of at least 25 years. And over this period, we ensure bitstream preservation of the data. Each published dataset it receives a DataSite DOI, and optionally it's also possible to reserve DOIs in advance. Datasets can be published with an embargo, either with a time-limited embargo period or even with an endless embargo. And datasets can be peer-reviewed externally before a publication. The data itself can be uploaded in different alternative ways via HTTPS protocol, via our user interface, via the browser, via our RADAR API, and also, and this is new since beginning of this year, we also support upload of data via the WebDAV protocol. Our RADAR metadata schema is generic and bases on the DataSite metadata schema. More than 20 different license types, including Creative Commons, are available to define the reuse of the dataset. And for example, further, it's possible to link to the dataset with other digital resources, for example, classical online publications via the related identifier field. After the publication, the metadata, they are automatically indexed in various formats and also transmitted to DataSite and offered also for public harvesting via our own FIZ Karlsruhe ORA provider, so that dissemination and findability of the data is ensured. RADAR4Chem datasets are, for example, findable in Google dataset search, in Base, B2Find, OpenAir, and as Christian said, in an NFDI4Chem search portal as well. Regarding authentication, users can log on either after a self-registration with a RADAR account or via a kind of single sign-on with their institutional ID, since RADAR support also the shibboleth. Yes, further, we daily create a knowledge graph and support a Sparkle endpoint. And last but not least, metrics on landing page views and download figures are available on each RADAR landing page. Yeah, here we see the RADAR4Chem portal where all publications are listed and can be accessed via the title hyperlink or, of course, directly via the DOI directly. You see also that currently we promote the FAIR4Chem Data Award in the page header, for which chemists can apply until this Sunday, I guess, yes. The 17th. And if time allows, we might have a closer look later in an online part after the Q&A session. Here we see the landing page of a data set itself. On the right frame, you have users can download the data set in whole or download the metadata, for example, in individual several formats. And in the central screen, we see the metadata which the data provider has entered before. Upload process and the data transfer to RADAR4Chem itself, it's a two-step data ingest and upload, which is also reflected then in a workflow for users to upload and publish the data. First, the data is uploaded in a so-called temporary storage. This storage is used for editing, for organizing the data, for the metadata annotation, for the data curation, and also for the peer review. And data can be transmitted either as individual files, as containers of files, and via the WebDAV protocol, it's also possible to upload several independent files and also individual folders without having zipped them before. Containers can be also unpacked during the upload, and during the upload, RADAR ensures data integrity by the calculation of the checksums. And this temporary storage itself is a redundant disk system, of course, with a daily backup. In the second step, when publishing the data then is transmitted to the permanent tape archive storages at KIT and TU Dresden, and thereby the dataset is packed as a TAR archive, TAR meaning tape archive format. And this TAR file, it uses a so-called Baggett standard, which is self-contained and self-describing. All necessary information then is included within, that is the research data. including the complete file and folder structure, all descriptive metadata, all necessary technical metadata, and some other information, as for example also the checksum of the files. And as I said, data is then secured geo-redundantly in 3 copies in the 3 locations on tape. Here we see the metadata editor. The metadata annotation can be done with help of this form-based editor, but also via an XML upload of a metadata file, or even via our RADAR API. A dataset can be annotated not only on the level of the dataset. This is of course mandatory, but it's also possible to do annotations on the level of individual folders and files. Our generic metadata schema has 10 mandatory fields and 13 optional metadata elements, and it uses a combination of free text fields, controlled vocabulary, and especially standard and authority data, for example, for persons, organizations, funders, and keywords. RADAR4Chem also supports subject-specific metadata schemas, and these schemas, they are uploaded as XSD files by the user or by us in the system before. However, for these schemas, we currently cannot yet offer such a form-based editor, and users have to upload XML files instead. Yeah, here you see a listing of all mandatory and optional metadata elements. You see all person names, that is creator, publisher, rights holder, and contributor element. Those person names can be enriched with an ORCID ID. We have an API to ORCID in place, and the ORCID ID is available then via an user-friendly suggestion list to pick from. And all organization names, as affiliation, as funding organization, for example, those can be enriched with standard data from RAW, the Research Organization Registry, and RAW entries, they are also available via an API as a type-ahead suggestion list to pick from. Same for the Crossword Funder Registry, available in the funder field, and which might not be so relevant for chemists, for the GND, the Gemeinsame Normdatei integrated authority file, which is available as type ahead option in the keyword field. Yeah, and as Christian said, metadata, they contribute significantly to the implementation of the FAIR principles, so that research data are findable, accessible, interoperable, and reusable for humans, and both for and also for machines. And throughout the last year, we worked intensively on further improving the fairness of our data sets. We, for example, also participated in a support measure of the European Fair Impact Project called Fair Assessment Challenge, and supported by mentors, we were able to further optimize the radar software during this measure, and thus increase the Fuji score as an indicator of the fairness for RADAR4Chem datasets to values up to 78%. And furthermore, since August last year, RADAR is also listed as a recommended generic or multidisciplinary repository for the journal Angewandte Chemie International Edition, and further details about this can be found here in the author guideline section D displayed here. And this is the result of NFDI4Chem's initiative or activities in the Editors for Chem initiative. I think Christian also has mentioned this before. Yeah. Then, these are already nearly my last slide. Now the question remains, how can I, or rather, how can you use RADAR4Chem? It's quite simple. Just contact us via email, state your subject area and your institution, describe your research project and the dataset plan for publication, for example, the size, number of files, the file formats, the planned publication date, and this information. Then we will advise you. And if the dataset is quite within the scope of RADAR4Chem, we will set up a separate work environment, a so-called RADAR4Chem workspace for you. And we authorize you as data provider, so-called curator, in this workspace. Please note, however, the maximum storage volume is 10 GB per research project. This is not a technical limit, which is much higher. The technical limit for RADAR4Chem is 600 GB, but it's a definition since we would like to make storage space available to as much chemists as possible. But if your data exceeds this limit, you can, of course, contact us nevertheless. And we will for sure find a solution for you. And then, as RADAR4Chem curator or data provider, you can start immediately working with RADAR4Chem. You can log on to the system, upload your research data, annotate it with metadata, optionally let the data review by external reviewers, and finally publish the data on your own. Upon the first or during the first upload, it is necessary that you agree to the RADAR4Chem license and user instructions, which are popped up and displayed online and shown here also on the right hand frame. And it's also worth knowing that research teams can also use RADAR4Chem, since our RADAR's rights and role model allows to define different responsibilities and set up workflows. So curators can assign so-called sub-curator rights to other users within their team. And those sub-curators can only upload data and annotate them with metadata, but cannot publish the data itself. So publication is exclusively reserved to the curators. And the complete upload and publication workflow and also the rights and role concept is described in our quick start guide available on our website, which offers a step-by-step instruction for data providers. And this would be the end of our presentation, at least for the theoretical part, and would like to thank you for your attention.